Okay, so today's topic is the power law and the change of base formula, also with a little bit of investment questions as well. And so let's begin with talking about what the power law is and the change of base formula. The power law is written here. It states that if I have a logarithm and the argument of the logarithm is raised to a power, I can actually take that and move it into the front of the logarithm and place a multiplication symbol there. Okay, I'll prove why this is true in class. Then the change of base formula is the same idea, a different idea. It says if I have a single logarithm with a base and an argument, I can write it as the quotient of two logarithms, where the base of the logarithm is now the argument of the logarithm in the denominator, and the argument of the previous logarithm is now the argument of the logarithm in the numerator, and I can actually choose whichever base I want, and that base can be any number, and they're both the same. Usually n is equal to 10. Usually. So let us do a couple practice questions with this. Here I've got a logarithm that's negative. There's log base 2 of 16 to the negative 2. Since the introduction of this new power law says, well, I can actually just take this negative 2 and write it over here. And so I could say a negative 2 of log base 2 of 16. Now log base 2 of 16 I can figure out mentally. The question is how many what do I need to raise 2 to in order to get 16? So I think if I raise it to 4, I will get 16, because 2 times 2 is 2 times 2 is nope, it's actually 5. And so this whole thing is 5 times a negative 2 times a negative. So in the end, this whole thing is 10. So all of this is equal to 10. Okay. And so now this one here, 2 log 3 of the square root of 27 is equal to x. So what I'll do is I'll change this to 2 log 3 of 27 to the 1/2. Just changing my square root into a fractional exponent. And then, so it's 2 times 1/2 of log 3 of 27. And what this is I've taken this 1/2 and moved it out front to make it become multiplication. And so this 2 and this 1/2 cancel, and I'm left with log 3 of 27. And I believe log 3 of 27 is 3, because 3 to the third power is 27. Now write as a single logarithm, or the quotient of logarithms. So this is already the quotient of logarithms. I'm going to rewrite it as a single logarithm. And so this is a simple practicing of the change of base formula. So if I have 2 logarithms in quotient form with a base of 10, for example, I can rewrite this as logarithm of 2 argument of 8. Going from here to here is sometimes not all that convenient. Maybe it can be, though. This is the more convenient way is writing a single logarithm as the quotient of logarithms. And so I would write this as log of 256 over log of 6, and I would choose the base 10. Generally speaking, I would choose the base 10 because now my calculator can actually figure out log 10 of 256 and log 10 of 6, rather than having to have me estimate, well, what do I need to raise 6 to in order to get 256, because I don't know that it's a whole number. I mean, 6 to the could be, who knows. I mean, 6 squared is 36, and 36 to the 6th. It actually could be 3. It's not. It's close to 3. It's a little bit over 3. Whatever the case, you got to plug it in, or estimate it as a little bit above 3. All right. So now let's look at an investment question. It says an investment of $300 earns 9% of interest, compounded annually. Annually is written over here. Okay, what does it mean to be compounded annually? That means the interest is applied once a year, and then any new money that's earned can now earn interest the following year. Okay, and so there's two questions. What amount of investment? What is the amount of the investment after 12 years? And then how long will it take for the investment to double? So let's look at part A. First of all, we need the equation here. And the equation for these is amount final is equal to amount initial times 1 plus the investment rate over T. And the time is in years. R is the rate of investment, or the annual interest rate. AI is the initial amount, and AF is the final amount of the investment. So what they're asking here is, what is the final amount of the investment of an initial amount of 300 at a rate of 9% after 12 years? So if I fill out this information here, I'm looking for the final amount. It's 300 times 1 plus 0.09 and 12 years. Why is it 0.09? Because 9% must be turned into a decimal in order for algebra to work. You can't do algebra on percentages, only decimals. And so there we have it. It simplifies down to 300 times 1.09 to the 12th. And there's a procedure that you'll need to, you'll want to figure out 1.09 to the 12th, then multiply it by 300. And so the amount final is 300 times whatever 1.09 to the 12th is. And I've got a calculator here on my computer, and it's let's see, 1.09 to the 12th is equal to, I'm getting 2.81. Okay, and then if I multiply that by 300, We get 843.80. So that's how you can figure out the investment. Simply just plug in 12 here, R here, 300 there. Now for the other one, which is really the reason why we're doing this section right now, is if you want to see how long it takes for your investment to double, then which is generally a good question. It's like, well, how long is it going to take for me to get at least $600 from this thing? How long does it take my $300 to make $300? Basically, $300 to make $300. And so you would start with amount final is equal to amount initial times 1 plus R over raised to the amount of time. Now this is going to be your unknown variable. You know that you want your final amount to be 600 because you're wanting it to double. Your initial amount is 300 and your rate is 1.09. And you're actually trying to solve for t. Now the algebra involved with trying to solve for this must be done in this way. You have to divide by 3 first, 300. And then you get 2 is equal to 1.09 to the t. And now you actually have to apply the definition of logarithms. So remember that the definition of logarithms says log of base 1.09 with argument 2 is equal to t. And there we have it. But this we can't really figure out. We can estimate it, but it'll be a poor estimation. So now we actually will use the change of base formula and write log of argument 2 over log of argument 1.09, and then bang, we use the change of base formula. So the time involved here is I'll just do this on my calculator over there. Log of 2 divided by log of 1.09. And we get the time of 8.04 years is how long it takes for your investment to double at the rate of 9%. And so there we have it. We use the change of base formula and the definition of logarithms from here and here. So this is the definition of logarithms, and this is the change of base formula. All right.